Hi, I warmly invite you to a lecture on the shoulder girdle. We will focus mainly on the two bones that you can see on the slide. I believe many people are not fully aware of how important the clavicle and scapula are for the mobility of the upper limb. These structures often seem unintuitive, since one might think that it would be enough to have only a glenoid cavity for the humerus placed on one of the ribs. However, in order to maximize the mobility of the upper limb, we were given a girdle, which we are about to discuss. To begin with, let us list the bones that belong to the shoulder girdle. Cingulum membri superioris. As the very name suggests, it is something that surrounds the axial skeleton, that is the vertebral column and the ribs. In the illustration, we have a posterior view of the thorax together with shoulder girdles. The scapula, singular in Latin also scapula, highlighted in blue, are displayed more prominently. In the background, we can also see the clavicles, singular in Latin clavicula, shown in burgundy. The next structures, such as the humerus, belong to the free part of the upper limb rather than the girdle itself. As for the names, the bone marked in blue is called the scapula due to its flat shape. On the other hand, the burgundy-colored structure is known in Latin as clavicula, which literally means little key. Whether this bone truly resembles that shape is something you will be able to verify on the following slides. We will begin with a detailed discussion of the clavicle. What do you think? Is this the right or the left clavicle? To make this decision, we need to determine whether we are looking at the superior surface or the inferior surface. And we also need to identify the ends of the clavicle. In this picture, we are looking at the superior surface, as it's smooth and lacks grooves or tuberosities. The next step is to recognize the two ends. The sternal end of the clavicle, extremitas sternalis, which forms the sternoclavicular joint, and the acromial end of the clavicle, extremitas acromialis, which forms the acromioclavicular joint. The acromial end is more distinctive as it has a more curved shape and is more massive. Meanwhile, the central part of the clavicle is simply referred to as the body, corpus. Therefore, we can conclude that the clavicle shown in our figure is the left clavicle. Now we have in front of us a clavicle with numerous irregular grooves, which tells us that we are looking at the inferior surface, still the left clavicle. Let us list the structures found on this side. The first feature is the impression for the costoclavicular ligament, impressio ligamenti costoclavicularis. This is simply the attachment for that ligament on the clavicle, here marked in orange. Since it is related to the sternoclavicular joint, it is located near the sternal end of clavicle. Moving toward the body, the next structure is the subclavian groove, sulcus subclavius, which serves as the attachment site for the muscle running along the clavicle. At the acromial end, we find the conoid tubercle, tuberculum conoideum. Close to it lies another feature, the trapezoid line, linea trapezoidea, which indeed resembles the shape of a trapezoid. The names of these two structures derive from the two parts of the coracoclavicular ligament, namely the conoid ligament and the trapezoid ligament. For this reason, these two features are often collectively described as the coracoid tuberosity, tuberositas coracoidea. Although this is not a term included in the standard anatomical terminology, it is a useful term that helps us remember the attachment of the coracoclavicular ligament, which we will discuss later in the lecture. We will move on the second bone of the shoulder girdle, the scapula, in Latin also scapula. It may seem that the scapula hangs in the air, but it is actually extensively covered with muscle attachments, which are located on the two surfaces. The costal one, or another name anterior surface, facies costalis, facies anterior, and the dorsal or posterior surface, facies dorsalis, facies posterior. On the right side, we have an interesting lateral view of the scapula, where both surfaces can be easily distinguished. Muscles also attach along the borders of the scapula, singular in Latin margo. The medial, medialis, superior, superior, and lateral, lateralis. The extreme parts of the borders form the angles, singular in Latin angulus. The superior, lateral, lateralis, and inferior. Let's examine the structure of the scapula more closely. In this case, it is easier to determine the sides, as the glenoid cavity is located laterally, whereas the scapular spine is on the dorsal side. Therefore, in this illustration, we are looking at the left scapula in an anterior view. The entire flat surface is called the subscapular fossa, fossa subscapularis. I have indicated its extent with a dashed blue line, and we can see that within it there are numerous elevated structures. These are the muscular lines, lineae musculares. Their function is to facilitate the attachment of the subscapularis muscle to the scapula. If we now look at the superior border, moving laterally from the superior angle, we encounter a small notch, indicated with a dark blue arrow. This is the scapular notch, incisura scapula, which forms a special passage for the suprascapular nerve. Moving even farther laterally, we come across a large, prominent anterior projection, the coracoid process, processus coracoideus. This is a remnant of the coracoid bone, which is present in reptiles and, of course, in birds. In humans, this process also serves as an important attachment point for ligaments and muscles. We rotate the bone to the dorsal side, where As I mentioned earlier, the scapular spine is located. Spina scapula, shown in light blue. It divides the posterior surface of the scapula into the supraspinous fossa, fossa supraspinata, and the infraspinous fossa, fossa infraspinata, which are important attachment sites for the muscles of the same names. The spine itself begins medially as the so-called triangular area of the spine of the scapula, trigonum spinae in Latin. It ultimately ends in the acromion, which forms part of the acromioclavicular joint. The foreign term originates from Greek and was used by Hippocrates himself. Akros, meaning highest or top, and omos, meaning shoulder. Thus, the acromion is the top of the shoulder, which is accurate because if we look for the most prominent bony structure in the shoulder region, it is indeed the acromion. To complete the overview of the scapula, let's look at it from the lateral side. The corresponding illustration is on the right side of the slide. The structure that dominates this view is the glenoid cavity, cavitas glenoidalis, shown in blue, which serves as the acetabulum for the shoulder joint. Above it is the supraglenoid tubercle, tuberculum supraglenoidale, and below is the infraglenoid tubercle, tuberculum infraglenoidale. These tubercles are important attachment points for muscles of the shoulder girdle and the arm, so they are worth remembering. In this illustration, it is also clear that the coracoid process, processus coracoideus, projects anteriorly, whereas the acromion is located posteriorly. Now let's look at the image on the left side, which shows the scapula in a posterior view together with the structures of the thorax. Here I want to point out the neck of the scapula, column scapulae, which connects the glenoid cavity to the rest of the scapula. I have highlighted it in green. Two more clinically relevant pieces of information. Certain bony structures are often used to determine position. The inferior angle of the scapula, angulus inferior scapula, is located approximately at the level of 7th thoracic vertebra, TH7, while the spine of the scapula, spina scapulae, is really at the level of 3rd thoracic vertebra, TH3. I think the dashed lines in the illustration represent this well. Before moving on the connections within the shoulder girdle, let's briefly discuss the scapular syndesmosis, syndesmosis scapulae. In the illustration, we have the left shoulder joint in an anterior view, but we will focus only on the fibers connecting the structures of the scapula. What draws particular attention is the connection between the coracoid process and the acromion. This is the coracoacromial ligament, ligamentum coracoacromiale. So the name is very intuitive. Notice also that this structure, in a way, broadens the acetabulum of the shoulder joint, and together with the mentioned processes, it is called the fornix humeri. This arrangement provides additional protection against superior dislocations of the shoulder joint. But that's not all. We mentioned a few slides ago the scapular notch, incisura scapulae. And in the image, we can see that the notch is bridged by the superior transverse scapular ligament, ligamentum transversum scapulae superius. Below the ligament runs the suprascapular nerve, and above it the suprascapular artery. This topography mainly results from embryological development and the vessels origin from the subclavian artery. But how can it be easily remembered? You can associate it with a military mnemonic: Army over, Navy under the bridge. Army, meaning artery, passes over the bridge, the ligament, while Navy, meaning nerve, passes under it. To complete the overview, I also show the posterior view of the shoulder joint and scapula. Since you have heard about the superior ligament, there is naturally also the inferior one. In this case, between the spine of the scapula and the posterior border of the glenoid cavity, there is the inferior transverse scapular ligament, ligamentum transversum scapulae inferius. Now it's time to discuss the connections. The first joint is the sternoclavicular joint, articulatio sternoclavicularis. We have a very good illustration showing this joint on both sides in the anterior view. The acetabulum for this joint is the clavicular notch of the sternum, incisura clavicularis sterni, while the head is the articular surface of the sternal end of the clavicle, facies articularis sternalis clavicle. Notice that there is an articular disc, discus articularis, within the joint cavity, which adapts the articular surfaces and increases the range of motion. In general, this joint can be classified as an irregular joint with spheroidal joint features. Let's list the ligaments that stabilize this joint. It is very logical and simple. Interclavicular ligament, ligamentum interclaviculare. This structure lies between the clavicles and it's shown in dark blue. Costoclavicular ligament, ligamentum costoclaviculare. Here we need to recall the impression for the costoclavicular ligament on the clavicle, and then everything fits together. This structure is shown bilaterally in maroon. Anterior and posterior sternoclavicular ligaments, ligamentum sternoclaviculare anterius et posterius. In the illustration, only the anterior ligament is labeled. Regarding mobility, it is worth mentioning that a clavicle fracture can increase the range of motion in this joint. This can produce the piano key sign, while pressing on the protruding end of the clavicle causes it to depress and then spring back to its previous position when released. Physiologically, full mobility like in a spheroidal joint is not possible because the acromial end of the clavicle also forms part of the acromioclavicular joint. This slide focuses on the acromioclavicular joint, articulatio acromioclavicularis. Here we can see some analogies to the sternoclavicular joint. as the articular surface of the acromial end of the clavicle serves as the site of the joint, while the articular surface of the acromion of the scapula serves as the acetabulum. Another similarity is the presence of an articular disc, although it is not visible in this illustration. Another analogy is that joint is also classified as irregular joint. It can also function like a spheroid joint. Regarding stabilization, there are two ligaments here. Acromioclavicular ligament, ligamentum acromioclaviculare, shown in maroon. As the name suggests, it attaches to the acromion and the acromial end of the clavicle, and therefore corresponds anatomically to the joint capsule. Second, coracoclavicular ligament, ligamentum coracoclaviculare, which attaches to the coracoid process and coracoid tuberosity of the clavicle. As mentioned earlier, this tuberosity consists of two distinct parts, the trapezoid line and conoid tubercle. Accordingly, the ligament can be divided in two separate bands: trapezoid ligament, ligamentum trapezoideum, shown in dark blue, and conoid ligament, ligamentum conoideum, shown in light blue. This is an example of why it is important to study anatomy thoroughly from the beginning, as much of anatomical terminology refers to osteological structures. In this way, we have concluded the topics related to the shoulder girdle. I hope you are now much more aware of the connections of the scapula and the clavicle. Very soon, as you study the next subjects, you will see how important a role they play in the mechanics of the shoulder thanks to the numerous muscular attachments. Do not neglect osteology, even if it may seem very simple, because then the next steps on your anatomical path may turn out to be insurmountable. Thank you very much for your attention. See you soon. School of Anatomy, Maciej Haberka.